Malolele, Nisa Purivinaka, and warm Pacific greetings to you all. My name is Eteroa, and welcome to Tautai Tech Skills Series, a series where we talk about all things tech. Today we're going to learn about
quantum computing.
What is quantum computing? So quantum computing in its simplest form is a design or a model of a type of computer that can process information using quantum mechanics. So it's quite sciencey, but hang in there, we'll get there together. Quantum computing is a rapid and emerging technology that really uses the law of quantum mechanics to really harness its power to solve problems. So let's really think of it like this. Normal computers process information by using bits, which are 0 to 1s, where quantum computing process quantum bits, which is the reason why it's able to process data faster than normal computers.
Why do we need this stuff?
Why we need these quantum computers is because of the power it enhances with connectivity and sharing data. As we mentioned before, normal computers and the way they process things is slower, but quantum computers or quantum computing in general is able to do that faster, as mentioned, but better and also smarter.
I'm stronger, I'm smarter, I'm better. I am better!
Quantum computing is a big talk in the industry, but especially in these 3 industry areas that I'll discuss now. So, areas that quantum computing are kind of used or researched at the moment is 1, science. So they use the quantum computing for quantum complexity, also spin-based quantum information, and quantum algorithms. So they really want to try and solve issues and problems in the science area with quantum computing.
So helpful.
Healthcare is another one where they kind of look at genetic information and how they can solve problems there, but also quantum computing is also used to discover treatment for those that are terminally ill. Last but not least is aviation, so calculating turbo power for highly fast jet planes and also measuring the amount of planes in a faster time span. And that's something that comes with quantum computing, and it's important that these 3 industries use these kind of technologies to help support them as well. So how does this work? Like, do we just plug it on the wall? Or unfortunately, we don't just plug it on the wall, because these computers are not cheap. There's only a few in the world, but we're going to just kind of understand the in the hood kind of vibe of what quantum computing is. So let's go into it. Number 1 is superposition. So a qubit, itself, so a qubit on its own is not useful, but it can perform an important trick. So placing the quantum information in it holds a state of superposition. So that kind of represents the combination of all possible configurations of a qubit. So groups of qubits or heaps of qubits of superposition can create complex, multi-dimensional and computational spaces. So remember, it's true what they say, it's better with numbers than by yourself, and that's the same with a qubit. So these complex problems that we face can be represented in ways in these spaces. So most commonly, computers use binary to store information in a state, like we mentioned before, 0 and 1s. However, with the quantum computing, we use stuff called qubits, and these qubits are like it's like a 0, 1, 0, 1, and that creates additional kind of states or ways to solve these problems. So instead of just having on and off, which is something that you get with a computer, in quantum computing you can either be on, off, or both at the same time, which is known as superposition. And that's kind of a lot of the technical and scientific side of how quantum computing works. Entanglement. So entanglement is a quantum mechanical effect that kind of correlates or kind of gets things running with the behavior of the two separate things that happen within quantum computing. When two qubits are entangled or like messed up, or like you just can't get it to, you know, untangle, it changes to one qubit to another. So it kind of changes its kind of behavior. So quantum algorithms really leverage with those relationships that are all complex, because even though it might look kind of messy, in the state of quantum computing, that itself is the key of solving these complex as problems.
It's pros and cons time.
So the pros of quantum computing is big calculations with faster calculations. You could give us 500 or 3 million equations for the quantum computing and they will be able to fix it and solve it really fast. Another one is protection. So protections to high volume attacks. So it's very good at protecting anything that you have. And the reason why is because it's so complex that it's even harder for those that hack to come in, and that's something that's quite useful. Databases, so quantum computers are able to execute and store more data at efficient time span compared to different other or normal classic computers. So they do it faster, better, and stronger. Now, the cons with this is hacking. It's easy for us to protect on the inside, but at the inside, but if someone else has a quantum computing, them to come and hack is even far efficient as well, as that too will be able to solve the problems or the things that we have that is protected by quantum computers. So it's something that's very on the radar for quantum computing, but it's interesting because even though it's good for protecting us, it's also not good at protecting other computers as well. It hasn't really been invented yet, if that kind of makes sense. I know we said that there's already been a few, but a lot of it is trial and error, because in order to create a quantum computer, it takes a lot of resources and also manpower to try and get that computer to do it. So it is to be expected at a decade in our home offices and stuff, but there are many things that are needed for the quantum computing to be in our everyday life. Like, it needs more research, needs more work in order for it to be able to be in the area that we live in and be able to support us with our work, because it's still in the research stage. People have built it, but they are monster big. So, and two, the cost of it is just insane. So that is kind of the pros and cons of quantum computing.
All done.
Thank you for joining me and learning about quantum computing. If you like this video, feel free to give us a like, or if you have any questions, make sure that you ask those questions in the comments below, and we'll try our best to answer them. Until next time, tō whāsoi fō, ma ia manuia.